Chapter 6. Witness to Genesis. Perhaps as an overreaction to creationism, scientists have considered the biblical tale of Genesis as a subject of faith, not fact. Yet, when one of the rocks brought back from the moon by Apollo astronauts turned out to be almost 4.1 billion years old, it was nicknamed the Genesis Rock. When a tiny piece of green glass shaped like a lima bean turned up in lunar soil samples gathered by the Apollo 14 astronauts, the scientists dubbed it the Genesis bean. It thus appears that in spite of all the objections and reservations, even the scientific community cannot escape the age-old faith belief. Gut feelings, or perhaps some genetic memory of the species called mankind, that a primordial truth underlies the narrative of the book of Genesis. However, the moon became a constant companion of Earth. The various theories will soon be examined. It, like Earth, belonged to the same solar system, and the histories of both go back to its creation. On Earth, erosion caused by the forces of nature as well as by the life that has evolved on it has obliterated much of the evidence bearing on that creation, to say nothing of the cataclysmic event that changed and revamped the planet. But the moon, so it was assumed, had remained in its pristine condition. With neither winds, atmosphere, nor waters, there were no forces of erosion. A look at the moon was tantamount to a peek at Genesis. Man has peered at the moon for eons, first with the naked eye, then with Earth-based instruments. The space age made it possible to probe the moon more closely. Between 1959 and 1969, a number of Soviet and American unmanned spacecraft photographed and otherwise examined the moon, either by orbiting it or by landing on it. Then man finally set foot on the moon when the landing module of Apollo 11 touched down on the moon's surface on July 20, 1969, and Neil Armstrong announced for all the world to hear, "Houston, Tranquility Base here. The Eagle has landed." In all, 6 Apollo spacecraft set down a total of 12 astronauts on the moon. The last manned mission was that of Apollo 17 in December 1972. The first one was admittedly intended primarily to beat the Russians to the moon. But the missions became increasingly scientific as the Apollo program progressed. The equipment for the tests and experiments became more sophisticated. The choice of landing sites was more scientifically oriented. The areas covered increased with the aid of surface vehicles, and the length of stay increased from hours to days. Even the crew makeup changed, to include in the last mission a trained geologist, Harrison Schmitt. His expertise was invaluable in the on-the-spot selection of rocks and soil to be taken back to Earth, in the description and evaluation of dust and other lunar materials left behind, and in the choice and description of topographic features, hills, valleys, small canyons, escarpments, and giant boulders, without which the true face of the moon would have remained inscrutable. Instruments were left on the moon to measure and record its phenomena over long periods. Deeper soil samples were obtained by drilling into the face of the moon, but most scientifically precious and rewarding were the 838 pounds of lunar soil and moon rocks brought back to Earth. Their examination, analysis, and study were still in progress as the 20th anniversary of the first landing was being celebrated. The notion of Genesis rocks to be found on the moon was proposed to NASA by the Nobel laureate Harold Urey. The so-called Genesis rock that was one of the very first to be picked up on the moon proved, as the Apollo program progressed, not to be the oldest one. It was only some 4.1 billion years old, whereas the rocks later found on the moon ranged from 3.3 billion-year-old youngsters to 4.5 billion-year old-timers. Barring a future discovery of somewhat older rocks, the oldest rocks found on the moon have thus brought its age to within 100 million years of the estimated age of the solar system, of 4.6 billion years, which until then was surmised only from the age of meteorites that struck the Earth. The moon, the lunar landings established, was a witness to Genesis. Establishing the age of the moon, the time of its creation, intensified the debate concerning the question of how the moon was created. The hope of establishing the Moon's origin was a primary scientific rationale for the manned landings of the Apollo project in the 1960s. James Gleick wrote in June 1986 for the New York Times Science Service. It was, however, the great question that Apollo failed to answer. How could modern science read an uneroded Rosetta Stone of the solar system, so close by, so much studied, landed upon 6 times, and not come up with an answer to the basic question? The answer to the puzzle seems to be that the findings were applied to a set of preconceived notions. And, because none of these notions is correct, the findings appear to leave the question unanswered. One of the earliest scientific theories regarding the Moon's origin was published in 1879 by Sir George H. Darwin, second son of Charles Darwin. Whereas his father put forth the theory regarding the origin of species, on Earth, Sir George was the first to develop a theory of origins for the Sun-Earth-Moon system based on mathematical analysis and geophysical theory. His specialty was the study of tides. He therefore conceived of the Moon as having been formed from matter pulled off Earth by solar tides. The Pacific Basin was later postulated to be the scar that remained after this pinching off of part of Earth's body to form the Moon. Although, as the Encyclopedia Britannica puts it so mildly, it is a hypothesis now considered unlikely to be true, the idea reappeared in the 20th century as one of 3 contenders for being proved or disproved by the lunar findings. Given a high-tech name, the fission theory, it was revived with a difference. In the reconstructed theory, the simplistic idea of the tidal pull of the Sun was dropped. Instead, it was proposed that the Earth divided into 2 bodies while spinning very rapidly during its formation. The spinning was so rapid that a chunk of the material of which the Earth was forming was thrown off, coalesced at some distance from the bulk of the earthly matter, and eventually remained orbiting its bigger twin brother as its permanent satellite. The thrown-off chunk theory, whether in its earlier or renewed form, has been conclusively rejected by scientists from various disciplines. Studies presented at the 3rd Conference on the Origins of Life, held in Pacific Palisades, California in 1970, established that tidal forces as the cause of the fission could not account for the origin of the Moon beyond a distance of 5 Earth radii, whereas the Moon is some 60 Earth radii away from the Earth. Also, scientists consider a study by Kurt S. Hansen in 1982, Review of Geophysics and Space Physics, Vol. 20, as showing conclusively that the Moon could never have been closer to Earth than 140,000 miles. This would rule out any theory that the Moon was once part of Earth. The Moon is now an average distance of about 240,000 miles from Earth, but this distance has not been constant. Proponents of the fission theory have offered various variants thereof in order to overcome the distance problem, which is further constrained by a concept termed the Roche limit, the distance within which the tidal forces overcome the gravitational force. But all variants of the fission theory have been rejected because they violate the laws of the preservation of energy. The theory requires much more angular momentum than has been preserved in the energy that exists to spin the Earth and the Moon around their axes and to orbit around the Sun. Writing in the book Origin of the Moon, 1986, John A. Wood of the Harvard-Smithsonian Center for Astrophysics, a review of hypotheses of formation of Earth's moon, summed up this constraint thus: "The fission model has very severe dynamic problems. In order to fission, the Earth had to have about 4 times as much angular momentum as the Earth-Moon system now has. There is no good explanation why the Earth had such an excess of angular momentum in the first place, or where the surplus angular momentum went after fission occurred. The knowledge about the Moon acquired from the Apollo program has added geologists and chemists to the lineup of scientists rejecting the fission theory. The Moon's composition is in many respects similar to that of Earth, yet different in key respects. There is sufficient kinship to indicate they are very close relatives, but there are enough differences to show they are not twin brothers. This is especially true of the Earth's crust and mantle, from which the Moon had to be formed, according to the fission theory. Thus, for example, the Moon has too little of the elements called siderophile, such as tungsten, phosphorus, cobalt, molybdenum, and nickel compared with the amount of these substances present in the Earth's mantle and crust, and too much of the refractory elements such as aluminum, calcium, titanium, and uranium. In a highly technical summary of the various findings, The Origin of the Moon, American Scientist, September-October 1975, Stuart R. Taylor stated, "For all these reasons, it is difficult to match the composition of the bulk of the Moon to that of the terrestrial mantle." The book Origin of the Moon, apart from its introductions and summaries, such as the above-mentioned article by J. A. Wood, is a collection of papers presented by 62 scientists at the Conference on the Origin of the Moon held at Kona, Hawaii, in October 1984. The most comprehensive since the conference 20 years earlier that had mapped out the scientific goals of the unmanned and manned moon probes. In their papers, the contributing scientists, approaching the problem from various disciplines, invariably reached conclusions against the fission theory. Comparisons of the composition of the upper mantle of the Earth with that of the Moon. Michael J. Drake of the University of Arizona stated, "rigorously exclude the rotational fission hypothesis." The laws of angular momentum place the comparisons of the composition of the Moon with that of Earth's mantle also ruled out after the landings on the Moon, the second favored theory, that of capture. According to this theory, the Moon was formed not near the Earth but among the outer planets or even beyond them. Somehow thrown off into a vast elliptical orbit around the Sun, it passed too closely to the Earth, was caught by the Earth's gravitational force, and became Earth's satellite. This theory, it was pointed out after numerous computer studies, required an extremely slow approach by the Moon toward the Earth. This capture process, not unlike that of the satellites we have sent to be captured, and remain in orbit around Mars or Venus, fails to take into account the relative sizes of Earth and Moon. Relative to the Earth, the Moon, about 1/80th the mass of Earth, is much too large to have been snared from a vast elliptical orbit unless it was moving very slowly. But then, all the calculations have shown, the result would be not a capture, but a collision. This theory was further laid to rest by comparisons of the compositions of the two celestial bodies. The Moon was too similar to Earth, and too dissimilar to the outer bodies to have been born so far away from Earth. Extensive studies of the capture theory suggested that the Moon would have remained intact only if it had neared Earth, not from way out, but from the very same part of the heavens where Earth itself was formed. This conclusion was accepted even by S. Fred Singer of George Mason University, a proponent of the capture hypothesis, in his paper, Origin of the Moon by Capture, presented at the above-mentioned Conference on the Origin of the Moon. Capture from an eccentric heliocentric orbit is neither feasible nor necessary, he stated. The oddities in the Moon's composition can be explained in terms of a Moon formed in an Earth-like orbit. The Moon was captured while forming near Earth. These admissions by proponents of the fission and the capture theories lent support to the third main theory that was previously current, that of co-accretion, a common birth. This theory has its roots in the hypothesis proposed at the end of the 18th century by Pierre-Simon de Laplace, who said that the solar system was born of a nebular gas cloud that coalesced in time to form the Sun and the planets, a hypothesis that has been retained by modern science. Showing that lunar accelerations are dependent on eccentricities in the Earth's orbit, Laplace concluded that the two bodies were formed side by side, first the Earth and then the Moon. The Earth and the Moon, he suggested, were sister planets, partners in a binary, or two-planet system, in which they orbit the Sun together while one dances around the other. That natural satellites or moons coalesce from the remainder of the same primordial matter, of which their parent planet was formed, is now the generally accepted theory of how planets acquired moons and should also apply to Earth and the Moon. As has been found by the Pioneer and Voyager spacecraft, the moons of the outer planets that had to be formed by and large out of the same primordial material as their parents are both sufficiently akin to their parent planets and at the same time reveal individual characteristics. as children do. This might well be true also for the basic similarities and sufficient dissimilarities between the Earth and the Moon. What nevertheless makes scientists reject this theory when it is applied to the Earth and the Moon is their relative sizes. The Moon is simply too large relative to the Earth, not only about 1/80th of its mass but about 1/4 of its diameter. This relationship is out of all proportion to what has been found elsewhere in the solar system. When the mass of all the moons of each planet, excluding Pluto, is given as a ratio of the planet's mass, the result is as follows: Mercury 0.0, no moons; Venus 0.0, no moons; Earth 0.0122, Mars 2 asteroids, Jupiter 0.21, Saturn 0.25, Uranus 0.17, Neptune 0.130. A comparison of the relative sizes of the largest moon of each of the other planets with the size of the Moon, relative to Earth, also clearly shows the anomaly. One result of this disproportion is that there is too much angular momentum in the combined Earth-Moon system to support the binary planets hypothesis. With all three basic theories unable to meet some of the required criteria, one may end up wondering how Earth ended up with its satellite at all. Such a conclusion, in fact, does not bother some. They point to the fact that none of the terrestrial planets, other than Earth, have satellites. The two tiny bodies that orbit Mars all are agreed, captured asteroids. If conditions in the solar system were such that none of the planets formed between the Sun and Mars, inclusive, obtained satellites in any one of the considered methods, fission, capture, co-accretion, should not Earth too, being within this moonless zone, have been without a moon? But the fact remains that Earth as we know it, and where we know it does have a moon, and an extremely large one, in proportion, to boot. So how to account toward that? Another finding of the Apollo program also stands in the way of accepting the co-accretion theory. The Moon's surface as well as its mineral content suggest a magma ocean, created by partial melting of the Moon's interior. For that, a source of heat great enough to melt the magma is called for. Such heat can result only from cataclysmic or catastrophic event. In the co-accretion scenario, no such heat is produced. How then explain the magma ocean and other evidence on the Moon of a cataclysmic heating? The need for a birth of the Moon with the right amount of angular momentum and a cataclysmic, heat-producing event led to a post-Apollo program hypothesis that has been dubbed the Big Whack theory. It developed from the suggestion by William Hartmann, a geochemist at the Planetary Science Institute in Tucson, Arizona, and his colleague Donald R. Davis. In 1975, that collisions and impacts played a role in the creation of the Moon, satellite-sized planetesimals and lunar origin, Icarus, Saturn, Leonard 24. According to their calculations, the rate at which planets were bombarded by small and large asteroids during the late stages of the planets, a formation was much higher than at present. Some of the asteroids were big enough to deliver a blow that could chip off parts of the planet they hit. In Earth's case, the blown-off chunk became the Moon. The idea was taken up by two astrophysicists, Alistair G. W. Cameron of Harvard and William R. Ward of Caltech. Their study, The Origin of the Moon, Lunar Science, Vol. 7, 1976, envisioned a planet-sized body, at least as large as the planet Mars, racing toward the Earth at 24,500 miles per hour. Coming from the outer reaches of the solar system, its path arced toward the Sun, but the Earth, in its formative orbit, stood in the way. To form, the Moon was shot up, with the force of the expanding vapor acting to distance the debris from Earth. Some of the ejected material fell back to Earth, but enough remained far enough away to eventually coalesce and become the Moon. This collision ejection theory was further perfected by its authors as various problems raised by it were pointed out. It was also modified as other scientific teams tested it through computer simulations. The leading teams were those of A.C. Thompson and D. Stevenson at Caltech, H.J. Melosh and M. Kipp at Sandia National Laboratories, and W. Benz and W. L. Slattery at Los Alamos National Laboratory. Under this scenario, lasting about 18 minutes in all, the impact resulted in immense heat, perhaps 12,000 degrees Fahrenheit, that caused a melting of both bodies. The bulk of the impactor sank to the center of the molten Earth. Portions of both bodies were vaporized and thrust out. On cooling, the Earth reformed with the iron-rich bulk of the impactor at its core. Some of the ejected material fell back to Earth. The rest, mostly from the impactor, cooled and coalesced at a distance, resulting in the Moon that now orbits the Earth. Another major departure from the original Big Whack hypothesis was the realization that in order to resolve chemical composition constraints, the impactor had to come from the same place in the heavens as Earth itself did, not from the outer regions of the solar system. But if so, where and how did it acquire the immense momentum it needed for the vaporizing impact? There is also the question of plausibility, which Cameron himself recognized in his presentation at the Hawaii conference. Is it plausible, he asked, that an extraplanetary body with about the mass of Mars or more should have been wandering around in the inner solar system at an appropriate time to have participated in our postulated collision? He felt that about 100 million years after the planets were formed, there were indeed enough planetary instabilities in the newborn solar system and enough protoplanetary remnants to make the existence of a large impactor and the postulated collision plausible. Subsequent calculations showed that in order to achieve the end results, the impactor had to be 3 times the size of Mars. This heightened the problem of where and how in Earth's vicinity such a celestial body could accrete. In response, astronomer George Wetherill of the Carnegie Institute calculated backward and found that the terrestrial planets could have evolved from a roaming band of some 500 planetesimals. Repeatedly colliding among themselves, the small moonlets acted as the building blocks of the planets and of the bodies that continued to bombard them. The calculations supported the plausibility of the Big Whack theory in its modified collision ejection scenario, but it retained the resulting immense heat. The heat of such an impact, Wetherill concluded, would have melted both bodies. This, it seemed, could explain A, how the Earth got its iron core, and B, how the Moon got its molten magma oceans. Although this latest version left many other constraints unmet, many of the participants in the 1984 conference on the origin of the Moon were ready. By the time the conference ended to treat the collision ejection hypothesis as the leading contender, not so much out of conviction of its correctness as out of exasperation. This happened, Wood wrote in his summary, mainly because several independent investigators showed that co-accretion, the model that had been most widely accepted by lunar scientists, at least at a subconscious level, could not account for the angular momentum content of the Earth-Moon system. In fact, some of the participants at the conference, including Wood himself, saw vexing problems inherent in the new theory. Iron, Wood pointed out, is actually quite volatile and would have suffered much the same fate as the other volatiles, like sodium and water. In other words, it would not have sunk intact into the Earth's core as the theory postulates. The abundance of water on Earth, to say nothing of the abundance of iron in the Earth's mantle, would not have been possible if Earth had melted down. Since each variant of the Big Whack hypothesis involved a total meltdown of the Earth, it was necessary that other evidence of such a meltdown be found. But, as was overwhelmingly reported at the 1988 Origin of the Earth conference at Berkeley, California, no such evidence exists. If Earth had melted and resolidified, various elements in its rocks would have crystallized differently from the way they actually are found, and they would have reappeared in certain ratios. But this is not the case. Another result should have been the distortion of the chondrite material, the most primordial matter on Earth that is also found in the most primitive meteorites, but no such distortion has been found. One investigator, A. E. Ringwood of the Australian National University, extended these tests to more than a dozen elements whose relative abundance should have been altered had the first crust of Earth been formed after an Earth meltdown. But there was no such alteration to any significant extent. In a review of these findings in Science, March 17, 1989, It was pointed out that at the 1988 conference, the geochemist Schiut contended that a giant impact and its inevitable melting of Earth do not jibe with what they know of geochemistry. In particular, the composition of the upper few hundred kilometers of the mantle implies it has not been totally molten at any time. Geochemistry, the authors of the article in Science concluded, would thus seem to be a potential stumbling block for the giant impact origin of the Moon. In Science and Technology, The Economist, July 22, 1989, it was likewise reported that numerous studies have led geochemists to be skeptical about the impact story. Like the previous theories, the Big Whack also ended up meeting some constraints but failing others. Still, one should ask whether, while this theory of impact meltdown ran into problems when applied to Earth, did it not at least solve the problem of the melting that is evident on the Moon? As it turned out, not exactly so. Thermal studies did indeed indicate the Moon had experienced a great meltdown. The indications are that the Moon was largely or totally molten early in lunar history. Alan B. Binder of NASA's Johnson Space Center said at the 1984 Conference on the Origin of the Moon. Early, but not initial, countered other scientists. This crucial difference was based on studies of stresses in the Moon's crust by Sean C. Solomon of the Massachusetts Institute of Technology, as well of isotope ratios, when atomic nuclei of the same element have different masses because they have different numbers of neutrons, studied by D. L. Turcotte and L. H. Kellogg of Cornell University. These studies, the 1984 conference was told, support a relatively cool origin for the Moon. What then of the evidence of meltings on the Moon? There is no doubt that they have occurred. The giant craters, some 100 or more miles in diameter, are silent witnesses visible to all. There are the Maria, seas, that, it is now known, were not bodies of water, but areas of the Moon's surface flattened by immense impacts. There are the magma oceans. There are glass and glassy material embedded in the rocks and grains of the Moon's surface that resulted from shock melting of the surface caused by high-velocity impacts, as distinct from heated lava as a source. At the third conference on the origins of life, a whole day was devoted to the subject of glass on. The Moon. So important was this clue held to be. Eugene Shoemaker of NASA and Caltech reported that such evidence of shock-vitrified glasses and other types of melted rock were found in abundance on the Moon. The presence of nickel in the glassy spheres and beads suggested to him that the impactor had a composition different from that of the Moon, since the Moon's own rocks lack nickel. When did all these impacts that caused the surface melting take place? Not, the findings showed, when the Moon was created, but some 500 million years afterward. It was then, NASA scientists reported at a 1972 press conference and subsequently, that the Moon had undergone a convulsive evolution. The most cataclysmic period came 4 billion years ago, when celestial bodies the size of large cities and small countries came crashing into the Moon and formed its huge basins and towering mountains. The huge amounts of radioactive minerals left by the collisions began heating the rock beneath the surface, melting massive amounts of it and forcing seas of lava through cracks in the surface. Apollo 15 found rockslides in the crater Tsiolkovsky 6 times greater than any rockslide on Earth. Apollo 16 discovered that the collision that created the Sea of Nectar deposited debris as much as 1,000 miles away. Apollo 17 landed near a scarp 8 times higher than any on Earth. The oldest rocks on the Moon were judged to be 4.25 billion years old. Soil particles gave a date of 4.6 billion years. The age of the Moon, all 2,500 or so scientists who have studied the rocks and soil brought back agree, dates back to the time the solar system first took shape. But then something happened about 4 billion years ago. Writing in Scientific American, January 1977, William Hartmann, in his article Cratering in the Solar System, reported that various Apollo analysts have found that the age of many samples of lunar rocks cuts off rather sharply at 4 billion years. Few older rocks have survived. The rocks and soil samples that contained the glasses formed by the intense impacts were as old as 3.9 billion years. We know that a widespread cataclysmic episode of intense bombardment destroyed older rocks and surfaces of the planets. Gerald J. Wasserberg of Caltech stated on the eve of the last Apollo mission. The remaining question, then, was, what happened between the origin of the Moon about 4.6 billion years ago and 4 billion years ago, when the catastrophe occurred? So the rock found by astronaut David Scott that was nicknamed the Genesis Rock was not formed at the time the Moon was formed. It was actually formed as a result of that catastrophic event some 600 million years later. Even so, it was appropriately named, for the tale in Genesis is not that of the primordial forming of the solar system, 4.6 billion years ago, but of the celestial battle of Nibiru Marduk with Tiamat some 4 billion years ago. Unhappy with all the theories that have so far been offered for the origin of the Moon, some have attempted to select the best one by grading the theories according to certain constraints and criteria. A truth table, prepared by Michael J. Drake of the University of Arizona Lunar and Planetary Laboratory, had the co-accretion theory far ahead of all others. In John A. Wood's analysis, it met all the criteria except that of the Earth-Moon angular momentum and the melting on the Moon. Otherwise, it bettered all others. The consensus has now focused again on the co-accretion theory, with some elements borrowed from the giant impact and fission theories. According to the theory offered at the 1984 conference by A.P. Boss of the Carnegie Institute and S.J. Peel of the University of California, the Moon is indeed seen as co-accreting with Earth from the same primordial matter, but the gas cloud within which the co-accretion took place was subjected to bombardments by planetesimals, which sometimes disintegrated the forming Moon and sometimes added foreign material to its mass. The net result was an ever larger Moon, attracting and absorbing other moonlets that were forming within the circumterrestrial ring, a Moon both akin to and somewhat different from the Earth. Having swung from theory to theory, modern science now embraces as a theory for the origin of our Moon the same process that gave the outer planets their multi-moon systems. The hurdle still to be overcome is the need to explain why, instead of a swarm of smaller moons, a too small Earth has ended up with a single, too large Moon. For the answer, we have to go back to Sumerian cosmogony. The first help it offers modern science is its assertion that the Moon originated not as a satellite of Earth, but of the much larger Tiamat. Then, millennia before Western civilization had discovered the swarms of moons encircling Jupiter, Saturn, Uranus, and Neptune, the Sumerians ascribed to Tiamat a swarm of satellites, 11 in all. They placed Tiamat beyond Mars, which would qualify her as an outer planet, and the celestial horde was acquired by her no differently than by the other outer planets. When we compare the latest scientific theories with Sumerian cosmogony, we find not only that modern scientists have come around to accepting the same ideas found in the Sumerian body of knowledge, but are even using terminology that mimics the Sumerian texts. Just as the latest modern theories do, the Sumerian cosmogony also describes the scene as that of an early, unstable solar system, where planetesimals and emerging gravitational forces disturb the planetary balance and, sometimes, cause moons to grow disproportionately. In The 12th Planet, I described the celestial conditions thus. With the end of the majestic drama of the birth of the planets, the authors of the creation epic now raise the curtain on Act 2, on a drama of celestial turmoil. The newly created family of planets was far from being stable. The planets were gravitating toward each other. They were converging on Tiamat, disturbing and endangering the primordial bodies. In the poetic words of the Enuma Elish, the divine brothers banded together. They disturbed Tiamat as they surged back and forth. They were troubling the belly of Tiamat by their antics in the dwellings of heaven. Apsu, the sun, could not lessen their clamor. Tiamat was speechless at their ways. Their doings were loathsome. Troublesome were their ways. They were overbearing. We have here obvious references to erratic orbits. I wrote in The 12th Planet. The new planets surged back and forth. They got too close to each other, banded together. They interfered with Tiamat's orbit. They got too close to her belly. Their ways, orbits, were troublesome. Their gravitational pull was overbearing, excessive, disregarding the other's orbits. Abandoning earlier concepts of a solar system slowly cooling and gradually freezing into its present shape out of the hot primordial cloud, scientific opinion has now swung in the opposite direction. As faster computers allow celestial mechanicians longer looks at the behavior of the planets, Richard A. Kerr wrote in Science, Research News, April 14, 1989, "Chaos is turning up everywhere." He quoted such studies as that by Gerald J. Sussman and Jack Wisdom of the Massachusetts Institute of Technology, in which they went back by computer simulations and discovered that many orbits that lie between Uranus and Neptune become chaotic, and that the orbital behavior of Pluto is chaotic and unpredictable. J. Lasker of the Bureau des Longitudes in Paris found original chaos throughout the solar system, but especially among the inner planets, including Earth. George Wetherill, updating his calculations of multi-collisions by some 500 planetesimals, Science, May 17, 1985, described the process in the zone of the terrestrial planets as the accretion of lots of brothers and sisters that collided to form trial planets. The process of accretion, crashing into one another, breaking up, capturing the material of others until some grew larger and eventually became the terrestrial planets, he said, was nothing short of a battle royal that lasted most of the first 100 million years of the solar system. The eminent scientist's words are astoundingly similar to those of the Enuma Elish. He speaks of lots of brothers and sisters moving about, colliding with each other, affecting each other's orbits and very existence. The ancient text speaks of divine brothers, who, disturbed, troubled, surged back and forth in the heavens in the very zone where Tiamat was, near her belly. He uses the expression battle royal to describe the conflict between these brothers and sisters. The Sumerian narrative uses the very same word, battle, to describe what happened, and recorded for all time the events of Genesis as the celestial battle. We read in the ancient texts that as the celestial disturbances increased, Tiamat brought forth her own host with which to do battle with the celestial brothers who were encroaching on her. She has set up an assembly and is furious with rage. Withal, 11 of this kind she brought forth. They thronged and marched at the side of Tiamat. Enraged, they plot ceaselessly day and night. They are set for combat, fuming and raging. They have assembled, prepared for conflict. Just as modern large size of the moon, so were the authors of the Enuma Elish. Putting words in the mouths of the other planets, they point to the expanding size and disturbing mass of Kingu as their chief complaint. From among the gods who formed her host, her firstborn, Kingu, she elevated. In their midst she made him great, to be head of her ranks, to command her host, to raise weapons for the encounter, to be in the lead for combat, in the battle to be the commander. These to the hand of king she entrusted. As she caused him to be in her host, "I have cast a spell for thee," she said to him, "I have made thee great in the assembly of the gods. Dominion over the gods I have given unto thee. Verily, thou art supreme." According to this ancient cosmogony, one of the 11 moons of Tiamat did grow to an unusual size because of the ongoing perturbations and chaotic conditions in the newly formed solar system. How the creation of this monstrous moon affected these conditions is regrettably not clear from the ancient text. The enigmatic verses, with some of the original words subject to different readings and translations, seem to say that making Kingu exalted resulted in making the fire subside, per E. A. Speiser, or quieting the fire god, per A. Heidel, and humbling, vanquishing the power weapon which is so potent in its sweep, a possible reference to the disturbing pull of gravitation. Whatever quieting effect the enlargement of Kingu may have had on Tiamat and her host, it proved increasingly disruptive to the other planets. Especially disturbing to them was the elevation of Kingu to the status of a full-fledged planet. She gave him a tablet of destinies, fastened it on his breast. Kingu was elevated, had received a heavenly rank. It was this sin of Tiamat, her giving Kingu his own orbital destiny, that enraged the other planets to the point of calling in Nibiru, Marduk, to put an end to Tiamat and her out-of-line consort. In the ensuing celestial battle, as described. Earlier, Tiamat was split in two. One half was shattered. The other half, accompanied by Kingu, was thrust into a new orbit to become the Earth and its moon. We have here a sequence that conforms with the best points of the various modern theories regarding the origin, evolution, and final fate of the moon. Though the nature of the power weapon, so potent in its sweep, or that of the fire god, that caused King to grow disproportionately large, remains unclear. The fact of the disproportionate size of the moon, even relative to the larger Tiamat, is recorded in all its disturbing details. All is there, except that it is not Sumerian cosmogony that corroborates modern science, but modern science that catches up with ancient knowledge. Could the moon have indeed been a planet in the making, as the Sumerians said? As reviewed in earlier chapters, this was quite conceivable. Did it in fact assume planetary aspects? Contrary to long-held views that the moon was always an inert object, it was found in the 1970s and 1980s to possess virtually all the attributes of a planet except its own independent orbit around the Sun. Its surface has regions of rugged and tangled mountains. It has plains and seas that, if not formed by water, were probably formed by molten lava. To the scientists' surprise, the moon was found to be layered, as the Earth is. In spite of the depletion of its iron by the catastrophic event discussed earlier, it appears to have retained an iron core. Scientists debate whether the core is still molten, for to their astonishment, the moon was found to have once possessed a magnetic field, which is caused by the rotation of a molten iron core, as is true of the Earth and other planets. Significantly, as studies by Keith Runcorn of Britain's University of Newcastle upon Tyne indicate, the magnetism dwindled away circa 4 billion years ago, the time of the celestial battle. Instruments installed on the moon by Apollo astronauts relayed data that revealed unexpectedly high heat flows from beneath the lunar surface, indicating ongoing activity inside the lifeless orb. Water vapor, was detected by Rice University scientists who reported, in October 1971, seeing geysers of water vapor erupting through cracks in the lunar surface. Other unexpected findings reported at the Third Lunar Science Conference in Houston in 1972 disclosed ongoing volcanism on the moon, which would imply the simultaneous existence near the lunar surface of significant quantities of heat and water. In 1973, bright flashes sighted on the moon were found to be emissions of gas from the moon's interior. Reporting this, Walter Sullivan, science editor of the New York Times, observed that it appeared that the moon, even if not a living celestial body, is at least a breathing one. Such puffs of gas and darkish mists have been observed in several of the moon's deep craters from the very first Apollo mission and at least through 1980. The indications that lunar volcanism may still be going on have led scientists to assume that the moon once had a full-fledged atmosphere whose volatile elements and compounds included hydrogen, helium, argon, sulfur, carbon compounds, and water. The possibility that there may still be water below the moon's surface has raised the intriguing question of whether water once flowed on the face of the moon. Water that, as a very volatile compound, evaporated and was dissipated into space. Were it not for budgetary constraints, NASA would have been willing to adopt the recommendations of a panel of scientists to explore the moon with a view to begin mining its mineral resources. 30 geologists, chemists, and physicists who met in August 1977 at the University of California in San Diego pointed out that research on the moon, both from orbit and on its surface, had been limited to its equatorial regions. They urged the launching of a lunar polar orbiter, not only because such an orbiter could collect data from the entire Moon, but also with a view to discovering if there is now water on the Moon. One target of the orbiter's observations, according to James Arnold of the University of California, would be small areas near each pole where the sun never shines. It has been theorized by scientists that as much as 100 billion tons of water in the form of ice are likely to be found in those places. If you're going to have large-scale activities in space, like mining and manufacturing, it's going to involve a lot of water. The Moon's polar regions could be a good source. Whether the Moon still has water after all the cataclysmic events it has undergone is still to be ascertained. But the increasing evidence that it may still have water in its interior and may have had water on its surface should not be surprising. After all, the Moon, alias King, was the leading satellite of the watery monster Tiamat. On the occasion of the last Apollo mission to the Moon, The Economist, Science and Technology, December 11, 1972, summed up the program's discoveries thus: "Perhaps the most important of all, exploration of the Moon has shown that it is not a simple, uncomplicated sphere, but a true planetary body." A true planetary body. Just as the Sumerians described millennia ago. And just as they stated millennia ago, the planet to be was not to become a planet with its own orbit around the sun, because it was deprived of that status as a result of the celestial battle. Here is what Nibiru Marduk did to, and Kingu, who had become chief among them, he made shrink. As a dug.ua.e god he counted him. As a dug. Ga. God he counted him. He took from him the tablet of destinies which was not rightfully his. He sealed on it his own seal and fastened it to his own breast. Deprived of its orbital momentum, Kingu was reduced to the status of a mere satellite, our Moon. The Sumerian observation that Nibiru Marduk made Kingu shrink has been taken to refer to its reduction in rank and importance. But, as recent findings indicate, the Moon has been depleted of the bulk of its iron by a cataclysmic event, resulting in a marked decrease in its density. There are two planetary bodies within the solar system, whose peculiar mean density implies that they are unique and probably the products of unusual circumstances. Alistair Cameron wrote in Icarus, Vol. 64, 1985. These are the Moon and Mercury. The former has a low mean density and is greatly depleted in iron. In other words, Kingu has indeed shrunk. There is other evidence that the Moon became more compact as a result of heavy impacts. On the side facing away from Earth, its far side, the surface has highlands and a thick crust, while the near side, the side facing Earth, shows large, flat plains, as though the elevated features had been wiped off. Inside the Moon, gravitational variations revealed the existence of compacted, heavier masses in several concentrations, especially where the surface had been flattened out. Though outwardly the Moon, as do all celestial bodies larger than a minimal size, has a spherical shape, the mass in its core appears to have the shape of a gourd, as a computer study shows. It is a shape that bears the mark of the Big Whack that compressed the Moon and thrust it into its new place in the heavens, just as the Sumerians had related. The Sumerian assertion that Kingu was turned into a dug. Ga. E is equally intriguing. The term, I wrote in the 12th planet, literally means pot of lead. At the time, I took it to be merely a figurative description of the Moon as a mass of lifeless clay. But the Apollo discoveries suggest that the Sumerian term was not just figurative, but was literally and scientifically correct. One of the initial puzzles encountered on the Moon was so-called parentless lead. The Apollo program revealed that the top few miles of the Moon's crust are unusually rich in radioactive elements such as uranium. There was also evidence of the existence of extinct radon. These elements decay and become lead at either final or intermediary stages of the radioactive decay process. How the Moon became so enriched in radioactive elements remains an unresolved puzzle, but that these elements had mostly decayed into lead is now evident. Thus, the Sumerian assertion that Kingu was turned into a pot of lead is an accurate scientific statement. The moon was not only a witness to Genesis, it is also a witness to the veracity of the biblical Genesis, to the accuracy of ancient knowledge.